right. Hey everyone, I'm Tom Hennen. I'm a UTL for Google's Software Supply Chain Security Program, and I'm also a SLSA Steering Committee member. Does this software do what it's supposed to do and nothing else? This is really the main question that we're trying to get at with all of our software supply chain security efforts, and there's really an awful lot to it. But so if some organization provides software and says that it is an image editor, why do we believe that what they give us is actually just an image editor, not a crypto miner or like something else that's going to cause us trouble? So one question is, why do we trust their intent? Why do we trust that they actually want to produce just this great image editor and nothing else? Now this is a very difficult problem to answer, but assuming that we can answer it, or like assuming that we trust them for whatever reason, the next question is, why do we trust that their process is one that the software that they wind up producing and delivering actually meets their intent, that the software that they build is what they intend it to be? So, as we know, there's a lot that can go wrong during software production, and just because an organization intends to produce good software doesn't mean that it actually happens. In the end, organizations are made up of various people and systems, and those people and systems are vectors for malicious behavior getting injected into the software. So it would be reasonable for consumers to wonder how they can be confident that the organization that's supplying them software has a good SDLC that is resistant to some of these threats. And it would also be very reasonable, more than reasonable, for organizations to ask themselves, how can we be sure that our SDLC is producing the software that we intend it to produce? Now, just a note, what do we mean by organization? Sometimes we say producer. We tend to use those interchangeably. Well, it's really the set of people that create the software. And in open source projects, this can be foundations, it can be multi-maintainer projects, it can be single maintainer projects, and of course it can also be companies or teams within companies. How can SLSA help with this problem? So first of all, SLSA v1 was launched in 2023 with the build track, but the overall goal of SLSA is to safeguard artifact integrity across the entirety of all supply chains. And one feature of SLSA is that it uses provenance and other attestations to enable verification of software at every stage within the SDLC. So you might have seen this before. This is how SLSA models the various threats that can occur within the SDLC. Over on the left, we see A, which is the threat of a producer with malicious intent. And over at I, we see the consumer actually using the software. And it would be very reasonable to ask, is the software that the producer intends to create what actually gets delivered over to the consumer at I? And in that process, we might ask, could the build or delivery of the software have been tampered with? And we might ask, could the source development process have been tampered with? Further, we can ask those same questions about all of the dependencies that are used within a software package and their dependencies and so on. So SLSA organizes its response to these threats into tracks. We have the build track, which asks if we can trust that the builder has faithfully converted the source code into the software package that got delivered. But of course, that begs the question, what's in the source code? So we have the source track, which is the focus of this talk, where we ask if we can trust that the source code actually represents the intent of the software producer. Further, we have the future build environment track, where we're asking if we can increase our ability to trust the builder. And we have a future dependency track, where we're asking if we can trust the dependencies that are used by the software package. Now onto the source track itself. So first of all, the source track is aimed at answering this question. Do we trust the source code to represent the intent of the builder? So this is tricky because source is built incrementally. Every revision is usually created by applying a small change on top of everything that came before it. But our controls don't usually apply to the entirety of the code base, but rather they apply to that change. And so a lot of the challenge of addressing source code security comes from the need to ensure that all of those incremental changes add up to what we actually want them to be. Now, why do we want to protect source at all? Well, we've certainly seen attacks against source code itself, and we also suspect that as we do our work to strengthen the integrity of the build process, that it will become relatively easier for attackers to achieve their goals by attacking source code. What types of attacks do we see against source code? So the basic one is just adding the malicious behavior itself directly to the source. We've seen that in a number of attacks in the last few years. And then we also see some sort of sweeteners on top of that. So we see the merging of unreviewable changes like binaries into source code repositories, as we saw with the XZ attack. We see the hiding of malicious commits, so that if a software package is built with malicious software in it, then an attacker will go back and remove that commit from the repository, so that then if you look at the source, everything looks fine and no one can see that malicious behavior. We saw that with the BoltDB Go attack. And we have also seen the abuse of tags to immediately impact users that are consuming those tags, as we saw with the TJ Actions changed files attack. Now, the source track is organized into 4 levels, and the basics are that at level 1, we require the use of a version control system. Yes, level 1, the use of a version control system. Level 2 is history retention and controls for protected branches and tags. Level 3 is the creation of signed provenance for every new revision that is introduced. And level 4 is requiring code review for every change that is introduced. So let's get into the specifics. Source level 1. We require that repositories and revisions are uniquely identifiable. This lets us point to the code that we're talking about and potentially locate it when we need to. And we also require the creation of source verification summary attestations, which let us talk about those revisions and communicate some high-level properties about them. This is an example source verification summary attestation, or source VSA. We can see here where it indicates the revision that the VSA refers to, the branches and tags that revision appears in, the repository that it came from, and the SLSA source level and any other high-level properties that revision meets. At source level 2, history and controls. Here we require that organizations indicate which branches and tags they are protecting and that they intend for people to actually use for production purposes. We require that history on those protected branches be retained so that people can go back and look and see what code was actually here for any particular revision. We require source control systems to implement and enforce change management process, which we'll talk about more in the next slide. And we require continuity for all controls on protected branches, so to try to prevent controls from being disabled, malicious changes from being introduced, and then controls being re-enabled. And finally, we require some identity management features that allow organizations to indicate who is allowed to make changes to the source and to attribute those changes to those accounts. So the enforced change management process. Here, source control systems are required to allow organizations to provide their own technical controls to be implemented when changes are introduced. And the goal here is really to help ensure that the source meets the intent of the organization, so that an organization can say, all code must be unit tested, it needs to have SAST and DAST tools run, it needs to be license compliant, it needs to have vulnerability scans, et cetera. And we also allow organizations to embed properties about these controls into the VSA, which can tell consumers what they should expect from this source. So in this example, if an organization has required unit testing, they can embed this org source tested property within the VSA. And they can do the same for any other properties that they might care to communicate. So at source level 3, we require the creation of source provenance. So every revision should have source provenance, and this provides details on how that revision was created. This is useful for detecting tampering with the revision history within the source control system. Now, SLSA does not define a standardized format for source provenance. Our current suspicion is that there are many different ways to architect source control systems, and a specific format that works well for all of them would be difficult to implement. So instead, we are requiring that organizations define and document how their source provenance format works, and we suggest that it use the in-toto attestations framework to do so. This is a sample provenance, and here we can see the revision that the source provenance. Pardon me, I should say this is sample provenance from one of our current implementations of the source track, and here we can see where it refers to the revision that it's talking about, how and who introduced it to this branch, the controls that were in place when that revision was introduced and how long those controls were in place, and when it was created and what preceded it in the history of the branch. And finally, level 4, we require code review. So for code review, we require that changes are agreed upon by 2 trusted people, and we do include the author of the change in those 2. Excuse me. And we also suggest that that the source control system provide tools that provide a method for reviewing binaries that are added to the repository. So if someone's adding a pre-built binary, they can also provide provenance, like SLSA build provenance that says what builder produced it, what source code it came from. The source control system could render that provenance so that the code reviewer sort of knows what they're doing without having to disassemble that binary. And this is really the best control that we have for detecting malicious source changes, but we leave it for level 4 because we also understand that it is also the most expensive control for people to implement. Now, is this SSH daemon a necessary maintenance feature or a backdoor? This is the type of question that we think is rather difficult for machines to answer, where you really need members of the organization to understand the intent of the organization and the designs around it and so forth. And these are things that are usually in people's heads and are very difficult for a machine to determine by itself. Now, how do we expect the source track to be used? So we expect that consumers will verify commits when they check out or build source, and they'll use the source VSA to check that revision. So here we see that a repository is being cloned, and that the tool is then run on that repository to verify that commit, and it will print out the various properties that revision meets. Further, we expect producers to go through a one-time setup process where they'll pick some source control system, they'll configure the branches and tags that are protected, and they'll configure any additional controls that they like for those branches and tags. We also expect that producers and consumers will occasionally want to do an audit of protected branches, and here we see an example of that, where we're auditing from one revision, going backwards in history, looking at every prior revision and calling out where there are gaps and potential problems, along with the controls that we think were in place, and a link so that users can follow up and see if there's anything suspicious happening. And finally, we expect that infrastructure providers will use SLSA to build source control systems that meet these requirements for users. Now, what exactly will they be building? So we expect that there are basically 3 different shapes for source control systems. There are monolithic systems where SLSA support is built directly on top of a source control platform like GitHub, GitLab, Perforce, etc. That there are over-the-top systems where SLSA support is added on top of an existing source control system by a third party, and that there are distributed source control systems where there's really no centralized source control platform, and instead the SLSA guarantees are met by distributed systems without any centralized infrastructure at all. So the current status of SLSA, we have version 1.2 RC1 is out for review and for your feedback today. you can go and check it out here and let us know what you think. We also have a couple of implementations that are under development. We have a GitHub workflow-based proof of concept, which runs using a GitHub Actions workflow. It uses native GitHub rule sets and relies on publicly defined policy to prevent regressions. We expect that this should be very easy for people that are already using GitHub to adopt and achieve up to SLSA level 4 if they wish. And there's also a there's also the GitTough project, which is an OpenSSF incubating project, and they're working on a SLSA Source Track implementation as well. The interesting thing about GitTough is that it can work on any Git host, but if you happen to be using GitHub, they do have an app to make that easier as well. And that's really all that I have. Does anyone have any questions? Okay. Yes, sir.
So did you put the two-person review in writing in 1.2 spec?
So the question is, did we put the two-person review requirement in writing in the 1.2 spec? Yes, we did.
Thank you.
Yes, sir.
Are the ESAs done on every single commit? Does the producer choose just
Yeah. Let's see. So the question is, if the VSAs are created for each commit or just for protected branches or tags. Is that correct? Yeah. So I suppose so. VSAs should be created for I think it might actually be undefined. They definitely need to be created for every commit on branches and tags. Implementations do have the option of only producing VSAs as required up to SLSA level 2. So you might only produce it if someone asks. But from SLSA level 3 and higher, at SLSA level 3, the provenance needs to be created contemporaneously with when the change is introduced, and the VSA must be based on the data within the provenance. So there we would expect that it would be when the change is created. Any other questions? Some back there.
Storage of these attestations. I guess one major difference between this and build track attestations is you're going to have far more attestations if they're produced with every single commit.
Yes. So we currently require that the source control systems do make it possible for consumers of the source to be able to access both the VSAs and the provenance for any of the revisions that they consume. We don't say how they need to do it. In our GitHub-based proof of concept, we're currently storing those attestations in Git notes for each revision. We would like to switch to the GitHub attestations API as soon as it adds support for storing attestations about commits.
If I want to get started with this in my organization, is there tooling I should use? Is there a repository I should watch?
Yeah. So I think that the two options would be these two implementations. You can go here now and check that out. And currently there is a getting started guide, which is a bit harder to use than we would like, but we have someone who's currently adding. Actually has just added support for automated onboarding of a repo that should make it much easier to enable. And then GitTough can be adopted as well today, but I would probably defer to Justin or Aditya for details on just where that is in terms of readiness. Great. Thanks, everyone.